Araceli, we are doing something a little bit different today. We are factoring, and instead of doing the notes for 3-4, which is factoring, I'm giving you this sheet, so you have to get this from me, okay? This is the homework page. The front side is the examples. So here we go. All right, ready?
Yeah.
We need to know what it is first and foremost that we are doing. So,
we don't know what we're doing.
Strategies. That's what I'm going to tell you. Okay, strategies. We have different methods to use. We have the GCF method, difference of squares, simple trinomial, complex trinomial. Example 5 is going to be a combination. So it's kind of like the mixed practice on the backside. You have the different categories and then you have mixed practice or mixed review, which means like maybe two things at once, right? Okay? All right, so we're going to go through all these methods, but essentially what it is that you are doing, it says when you are factoring, you are finding the zeros. We know how to find zeros on a graph, right? If they give me a coordinate plane and they have like, let's say this thing on here, the zeros are this number and this number, whatever they may be. Maybe it's -1 and +5. I have no idea. That's what we are trying to locate. But I don't want to have to graph every time. I want to be able to do it without graphing. Shh, you got to listen. This stuff is hard, and as soon as you know it, you know it. You're good, but you got to listen. Graphing. I don't want to have to graph every single time to find those zeros, so we're going to do it by factoring, okay? And one of the first methods of factoring is the GCF method. Now, the GCF method might not give you the zeros to start with, but it will help you simplify a problem so that you can do a different method in conjunction with GCF, okay? So the greatest common factor is finding something that all of the terms have. First and foremost, how many terms do we have here? 3. 1, 2, 3 chunks, right? All right, looking at just the numbers, 9 and 3 and 12. What number goes into all of those numbers? 3. That is the greatest common factor for the numbers, all right? Then we have x to the 4th, we have x to the 3rd, and we have x squared. How many can you pull out? 2. I can pull an x squared out of everything, right? I can't pull 3 of them because this one doesn't have 3 to give me, right? It's like this one has $4, this one has $3, this one has $2. I can take $2 from everybody, but I can't take 3 because this one only has $2, right? Okay? So 3x squared is the GCF. This is my GCF guy. Now, when you take it out, you don't throw it in the trash can. You pull it out front, and then you put a parenthesis of what's left over after you take it out. You don't throw it away. You leave it out front. Okay? Now we're going to go back through, and we're going to say what's left over. So if I look at 9 and I pull out 3 or divide by 3, you're going to have 3 left over. How many x's will be left over? 3x squared, okay? If I were to multiply those back together, you should get 9x to the 4th power. Got it? All right, so let's do the next one. 3x to the 3rd. If I divide by 3, it would be like +1. You don't have to have the 1 there, but he just needs an x, yeah? Okay? Now the 12, if I divide by 3, he will need to have 4x to the nothing, no x. So we just leave +4, okay? If you want to check your answer, you can multiply them back through. If I multiply those together, that's 9x to the 4th. If I multiply that, that is 3x to the 3rd. If I multiply that, that is +12x squared. Does he match? Yep, so he's good. So this is what I'm trying to get to. The GCF is pull that number out front or that chunk out front, write what's left over. Got it? That's the GCF method, okay? There's nothing to graph on that because usually you use GCF to then help you find another method, okay, to solve for. Ready? All right. Difference of squares. We're going to talk about difference of squares and how you know it's a difference of squares. What does the word difference mean? Subtract, okay? And a square means like a perfect square, right? Perfect squares are like 4 and 9 and 16 and 25 and 36 and 49 and so on and so forth, right? You continue on forever, right? We're looking at perfect squares. Got it? So the difference or subtracting numbers that are square or pieces that are square, right? Here we are subtracting and I'm looking at 16 and I'm looking at 36, right? Okay, those are perfect squares. All right, here's how you do this. This is the easiest way possible. It is literally 2 pieces and that's all. Got it? You do 2 little chunks. Are you watching? Blink and you miss it because this is a really fast method. This is my favorite of all of them. Okay, really fast. You look at this first chunk, which is 16x squared, and you take the square root. What's the square root of 16x squared? 4x, right? The square root of 16 is 4, the square root of x squared is x, right? So I put 4x there and I put 4x there. Okay, then I do the same thing with 36. What's the square root of 36? 6 and 6, right? So the first piece is 4x, the last piece is 6. One of them is plus, one of them is minus. Have you done this before?
Oh my gosh, we done
Hey, you've done this before. Okay, now we're going to take it one step further though, because this right here, you got to listen. This right here is a quadratic function, which means he's a parabola, right? And we're going to try to graph him and figure out what he looks like. I don't know. We're going to graph him. But what I'm going to do is, now that I have him factored down, we still have him equal 0. Got it? Which means that I take this chunk and I say 4x plus 6 equals 0. That's the first chunk. And then I say 4x minus 6 equals 0. Okay? All right, if 4x plus 6 equals 0, I'm just taking each of the pieces and separating them and setting them equal to 0. That's the way it works, right? Okay? If I have 4x plus 6 equals 0, I'm going to solve for x, so I subtract the 6. So I have 4x equals negative 6, okay? And then I divide by 4. Negative, that's the other way around. Negative 3 over 2, which is negative 1.5. If you divide and you want a decimal, that's fine. Negative 1.5 is what he will be, okay? Then I do the same thing over here. I add the 6, and I have 4x equals 6, and I divide by 4, so this time it is positive 1.5. Just as a little hint, when you do difference of squares and you solve and you get it all the way down, you have x equals something and x equals something. One of them will be positive, one of them will be negative, but it will be the same. Yeah, it will be the same number, right? That's the way that it will work. Okay, so what that allows me to do is I have, let's see, 1, 2, and negative 1, negative 2. So 1.5 is where he touches here, and 1.5 is where he touches there. Now, what is his y-intercept? Go back to the original. Negative 36. Negative 36. So this y-intercept is like all the way down here, and that's what it looks like, right? That's my parabola. Something like that, okay?
That big smiley
Yeah.
face.
If you want to just put mark 36 right here, negative 36, and just have him be like not crazy weird. This is 1.5 and this is negative 1.5. So your units won't be quite right because we don't want to run into the next problem, but that's what he will look like, right? So we have successfully found where he's touching without actually having to graph first. We graphed it at the end, right? But you wouldn't have to graph it all if that's the case, right? We have those two numbers, and that is a difference of squares, yeah? Do you want to go and do a homework problem of a difference of squares before we
Yes,
move on to the next section? Okay, so no, you don't have to graph any of these. You don't have to graph any of these, okay? You're just factoring them down, okay? All right, would you like to do 7, 8, or 9 together?
all of the above.
Let's do 8. Can I do 8? Because that one has a Y also.
No, we got that.
Yeah, do 8.
8?
Eight.
8? Let's do this one. Okay, now, take a look at the difference really quick. Take a look at the difference between 8 and 11. What do you notice?
It's just
It's easy.
It doesn't even
This one doesn't have equal 0 on the end of it. So, are you listening? If it does not have equal 0, you get to just do this part and then stop.
Actually,
If it does have equal 0, you have to do this, and then you have to do this guy equals 0, this guy equals 0, and solve. Do you see the difference between the two? Okay.
3x plus 7.
So this one right here, number 8, he is a difference of squares. Let's talk through how we know that. Is he a difference?
Yes.
Because he is minus. Is he 2 squares? Like, can I take the square root of 9x squared? Can I take the square root of 49y squared? Then he is a difference of squares. Got it? Now, a difference of squares will only have 2 pieces, right? 2 pieces. All right, so what is the square root of 9x squared? 3x. He goes here and he goes here. Okay? The square root of 49y squared is 7y. One goes here and one goes here. What goes in the middle? Plus and minus. Now, does it matter if you do minus and then plus?
No.
No, it doesn't matter which one's first.
Teachers, please dismiss the high school volleyball player.
There you go. This problem is done. This problem is done. We don't have to set equal to 0. He is done. Got it? Okay?
Also, can I please have the junior high?
I will send this to you. You guys can skip like partway through. You can skip the first 9 minutes. We'll be 9 minutes and 40 seconds in.
Oh, they are?
Okay.
Okay? All right, so that problem is done. Happy with that?
Yeah.
Difference of squares. Okay? Difference of squares. Now, the rest of them are difference of squares as well, but, you know, like, yeah. That's it. Got it? All right, let's do the next category. Next category is something called a simple trinomial. Okay, let's talk about how we know he's a simple trinomial. The word simple. There's two things that a simple trinomial thing must have. The word trinomial, let's start with that. What does tri mean? Three. He has 3 pieces. A trinomial has 3 pieces. It is simple because the first term
It's always X.
is just x squared. There's no number in front of here. A equals 1, in other words.
1, not 0.
Not 0. A equals 1. The number in front of x squared is a 1, right? If there's no number, it's 1. Okay, so that's what makes him a simple trinomial. Now let's go over and just compare him to a complex trinomial. Complex trinomial has 3 pieces as well. You see this guy? Except, number 2, he is complex because
A has to be greater than 1.
there is a number in front of x squared. Now, it doesn't have to be greater than 1. It just has to be a number other than 1. Technically, it could be like 1/2 or 1/3, which is really
Or it could
ugly.
be negative.
Okay, or it could be
What does it mean?
negative
Exactly.
1, technically, yeah.
Something besides
Or
1.
Something besides 1. So you have a number in front of your x squared. That's the thing that makes him complex. I'll show you how to do him in here in a second. Okay, but let's go back to the simple ones. This is another really, really easy method. Just like difference of squares. You have 2 bubbles. Okay? You have to think a little bit more than maybe a difference of squares. Okay? But here's how a simple trinomial works. You are looking at this number, which is your ending number, and you are trying to multiply to get that ending number. And you are trying to add to get the middle number. So I want 2 numbers that I can multiply to get 18, but when I add them, give me 3. Okay? If you are stuck and you don't know right away, let's make a chart. So I want numbers that can multiply to give me negative 18. So I have 1 and 18, which is obviously not it. If I add those together, will I get 3?
No.
No. 2 and 9. If I add those together somehow, can I get 3?
No.
No. 3 and 6. Can I add those together in such a way that I get 3?
You can't add those together.
One of them will have to be negative though.
Yeah.
Yes, right. But some combination of 3 and 6 will give me a positive 3. I want the 3 to be positive. So which number has to be negative?
Negative 6.
Negative 3 plus 6.
Yeah.
Right? In order to be a positive 3. Got it? Okay? So if you can't think of it, make a chart. Make a list. All right? So when I do this, x goes here and x goes here. My 2 numbers were which ones? Negative 3 and positive 6. That's exactly how it goes. X minus 3, x plus 6. How easy is that?
That's it?
Now, that's it. Well, we have to set it equal to 0 now. Okay? So when we do that, if you want to check your answer, you guys know how to FOIL from doing complex numbers, right, with the eyes, right? X times x is x squared. X times 6 is 6x. Minus 3x, which together makes just 3x. And then negative 3 times 6 is negative 18, right? You can FOIL and get back to the original. So factoring is like reverse FOILing, right? Like FOIL to get it put together, you factor to get it broken apart into 2 groups, okay? Yes, sir.
Does it matter which?
Does it matter? Could you write it as x plus 6 and then x minus 3? Does it matter that way? No, it does not.
It doesn't.
No. What does matter, Jace, is you want to make sure that you don't put plus 3 and then minus 6, because plus 3 and minus 6 will make this a negative 3. Does that make sense? So that's what you don't want to avoid doing, okay? Now, this is set equal to 0, so I have to do x minus 3 equals 0, and then I have to do x plus 6 equals 0. These ones you can do in your head. If x minus 3 equals 0 and I add the 3 over, x will be?
X equals 3.
X equals 3. It's exactly the opposite sign of what it's in the parentheses, right? Okay? You really don't even need to write it down. Minus 6, x equals negative 6, right? Okay? So that means at 1, 2, 3, 4, 5, 6 negative, he's going to have a dot. And at 1, 2, 3 positive, he's going to have a dot. Okay? Where is he going to intersect the y-axis? What's his y-intercept? Negative 18. You guys remember that from section 1?
Do we have to graph them though?
I'm graphing him right now. You won't have to graph him on your homework assignment. I'm just trying to put the dots together so you understand what we're actually finding, right? I want you to graph him now so you know what we're finding, but on the back side, you don't have to graph any of them, okay? This is just illustrating what we're finding. Negative 6, positive 3, those are the those are the x-intercepts. Yes, sir.
Never mind.
Okay. That is a simple trinomial. Would you like to do one on your homework?
Yes, please.
Yes, okay. Pick one of the simple trinomials. Which one looks nasty?
16.
16? 16 looks sucky?
Yeah, just
Okay.
plus is really high.
Sure. Yeah, because 40 is a big number. Okay? Now, do we have to eventually set this guy equal to 0?
Yeah.
Yes, we do, because he has equal 0. All right, I want to multiply to give me 40, but when I add them, give me 14. Okay? So if you can't figure it out, 40 is 1 and 40, or 2 and 20, or 3 doesn't go in there, 4 and 10, or
Negative 10.
5 and 8. Those are my combinations. Which one will give me negative 14? You've already figured it out. 4 and 10, except both of them will have to be negative. Negative 4 and negative 10. Got it? Okay, so my bubbles. I call these little bubbles. Okay? X goes here and X goes here. My two numbers were
-4.
negative 4 and
-10.
negative 10.
X equals 4, X equals 2.
Yep. So if I set X minus 4 equal to 0 and I add the 4 over, right? You can do this in your head. X equals 4. That's one of my zeros or one of my X-intercepts. The other one, X minus 10, you add the 10 over and X equals
10.
positive 10. You see how we get that?
I do.
Yeah.
Actually, really easy.
This is actually not too bad. And you should have maybe had these last year. Did you have these last year?
Yeah.
Yeah. Except you solved the simple trinomial. I know Ella yesterday. Ella, if you're listening to this video, you were telling me yesterday how you solved a simple trinomial, but I think you did it by like the complex method. We're going to see that here in a second. Okay. So